Adapting to altitude, how species survive in high mountains. Adapting to altitude, how species survive in high mountains. The world's high mountains possess an undeniable appeal, with their majestic peaks and breathtaking landscapes. However, what might seem like a paradise for adventure seekers can be a challenging environment for living organisms. The thin air, extreme temperatures, and lack of oxygen make survival a daunting task. Yet, against all odds, various species have managed to adapt and thrive in these harsh conditions. In this article, we will explore the remarkable ways in which organisms have evolved to survive in high-altitude environments. One of the primary challenges faced by organisms living at high altitudes is the scarcity of oxygen. As we ascend, the atmospheric pressure decreases, causing a reduction in the availability of oxygen and molecules. To counteract this limitation, many animals and plants have developed physiological adaptations. For instance, some mammals, such as the Tibetan yak, have larger lung capacities, allowing for increased oxygen intake with every breath. Similarly, birds like the bar-headed goose possess specialized hemoglobin that binds to oxygen more efficiently, enabling them to fly over the world's tallest mountains during migration. Plants, too, have devised intriguing mechanisms to cope with reduced oxygen levels. Take the case of the cushion plants, which are commonly found in high-altitude regions. These plants grow in compact, low-lying formations, which helps to trap air and create a microenvironment with higher oxygen concentration. Additionally, some high-altitude plant species exhibit increased rates of photosynthesis, enabling them to generate the necessary energy with limited resources. Another key challenge in high-altitude environments is temperature fluctuation. Mountains experience dramatic temperature changes throughout the day and night, with freezing temperatures being a common occurrence. In response, organisms have evolved various strategies to regulate their body temperatures and minimize heat loss. Many animals, such as the snow leopard, have thick fur that provides insulation, while also helping them blend into their snowy surroundings. Similarly, the Tibetan antelope has a dense coat of fur that traps heat close to its body during the frigid winters. In addition to insulation, animals inhabiting high altitudes have developed efficient energy conservation mechanisms. For instance, some species, like the pikas, enter a state of torpor during extreme cold periods when food is scarce. Torpor is a state of decreased metabolic activity, allowing animals to conserve energy and survive for extended periods without eating. This adaptation helps them endure the long, harsh winters typically encountered in high mountains. Adapting to the extreme conditions of high-altitude environments also involves making the most of available resources. This is evident in the feeding habits of many species. For instance, the Himalaya marmot can dig deep burrows in the frozen ground, where it hibernates during the winter months and stores food. By utilizing these burrows, the marmot can survive on its stored provisions when aging opportunities are scarce. Furthermore, the scarcity of resources in high-altitude regions has led to the evolution of specialized diets. The snow leopard, for example, primarily preys on herbivores like the Himalayan blue sheep, which have adapted to feeding on sparse alpine vegetation. By targeting these herbivores, the snow leopard ensures a steady food supply. Similarly, some bird species, such as the Himalayan Manal, have evolved long beaks to reach deep into the ground for insects that may be hidden beneath the snow during colder seasons. Surviving in high mountains also requires adaptations to cope with the increased exposure to ultraviolet (UV) radiation. With every 1,000 meters increase in altitude, UV radiation levels can increase by up to 10%. To shield themselves from this potentially harmful radiation, many species have developed physical defenses. Some plants produce compounds, like UV-absorbing pigments, that act as a protective shield against the sun's rays. Animals, on the other hand, may have thicker skin or feathers to reduce UV penetration or engage in behaviors such as seeking shade during the peak hours of sunlight. The ability to survive and thrive at high altitudes is not limited to individual species, it also extends to the intricate ecological relationships that exist within these environments. Organisms have eco-evolved and formed highly specialized connections to ensure their mutual survival. For example, several plants rely on specific insects for pollination, with both organisms evolving specific adaptations to fulfill their respective roles. Similarly, herbivores have developed preferences for consuming certain plants, creating a delicate balance between predator and prey. The adaptability of organisms to high-altitude environments is a testament to their resilience and ingenuity. Despite the thin air, extreme temperatures, and limited resources, different species have found unique ways to survive and thrive in these challenging conditions. One crucial obstacle faced by organisms in high-altitude regions is the scarcity of oxygen. As altitude increases, the atmospheric pressure decreases, making it more challenging for organisms to obtain insufficient oxygen for survival. However, many animals and plants have developed physiological adaptations to overcome this hurdle. For instance, some mammals, including the Tibetan yak, have large lung capacities, enabling them to intake more oxygen with each breath. Birds like the bar-headed goose possess specialized hemoglobin that binds to oxygen more efficiently, allowing them to migrate over the world's tallest mountains. Plants, too, have devised fascinating strategies to cope with reduced oxygen levels. Cushion plants, commonly found in high-altitude regions, grow in compact formations close to the ground. This grow pattern helps trap air and create a microenvironment with a higher concentration of oxygen. Additionally, some high-altitude plant species exhibit an increased rate of photosynthesis, allowing them to generate necessary energy despite limited resources. Temperature fluctuations are another significant challenge in high-altitude environments. Mountains experience drastic changes in temperature throughout the day and night, with freezing temperatures being a common occurrence. However, organisms have evolved various mechanisms to regulate their body temperatures and minimize heat loss. Many animals, like the snow leopard, have developed thick fur that provides insulation, aiding in both temperature regulation and camouflage. Similarly, the Tibetan antelope's dense coat of fur traps heat close to its body during frigid winters. Efficient energy conservation is also crucial for survival in high-altitude environments. Some species, such as the pikas, enter a state of torpor during extremely cold periods when food is scarce. Torpor allows animals to decrease their metabolic activity, conserving energy and enabling them to survive for extended periods without eating. This adaptation helps them endure the long, harsh winter. Typically encountered in high mountains. Making the most of available resources is essential in high-altitude regions characterized by scarcity. Many species have developed specialized feeding habits to adapt to this challenge. For instance, the Himalayan marmot digs deep burrows in frozen ground, where it hibernates during winter and stores food. By utilizing these burrows, the marmot can survive on stored provisions during times of food scarcity. Furthermore, the limited availability of resources in high-altitude regions has led to the evolution of specialized diets. The snow leopard, for example, primarily preys on herbivores like the Imala. Yan blue sheep, which have adapted to feeding on sparse alpine vegetation. By targeting these herbivores, the snow leopard ensures a consistent food supply. Similarly, bird species such as the Imala Yan manal have developed long beaks to reach insects buried under the snow during colder seasons. Surviving in high mountains also necessitates adaptations to cope with increased exposure to ultraviolet (UV) radiation. With every 1,000 meters increase in altitude, UV radiation levels can rise by up to 10%. To protect themselves from the potentially harmful effects of UV radiation, many species have developed physical defenses. Some plants produce compounds, such as UV-absorbing pigments, the T act as a shield against the sun's rays. Animals, on the other hand, may have thicker skin or feathers to reduce UV penetration or engage in behaviors like seeking shade during peak sunlight hours. The ability to survive and thrive in high-altitude environments extends beyond individual species. It involves intricate ecological relationships that exist within these ecosystems. Organisms have evolved to form highly specialized connections to ensure their mutual survival. For example, several plants rely on specific insects for pollination, with both the plants and insects evolving adapted ions to fulfill their respective roles. Similarly, herbivores have developed preferences for consuming certain plants, creating a delicate balance between predator and prey. High-altitude environments present challenges for living organisms, with thin air, extreme temperatures, and limited resources. However, various species have adapted and thrived in these harsh conditions. Ions. Let's explore how organisms have evolved to survive in high mountains.